All right, so right before Thanksgiving, we were in these 6-1 notes and we were talking about a discrete random variable. And if we scroll down on these notes beyond what we did in class before, just as a quick review, we'll look at this example dealing with the number of goals scored by an NHL hockey team during a randomly selected game. So if you take all games of this NHL hockey team, they score anywhere between 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9 goals with the corresponding long run probabilities listed below. So 1, verify this is a legitimate probability distribution, and that would be if the sum of the probabilities is 1.0. Which it is. You can verify that on your own if you'd like. Now, because we're dealing with something quantitative, we can do all of the stuff we did in Chapter 1, like create graphs and summary statistics. So one of the ways we can display the distribution of this random variable is in a probability distribution histogram. So we talked about how to make histograms way back in Chapter 1. Histograms are two-dimensional graphs. There's a horizontal and a vertical axis. The horizontal axis is going to be the variable we're interested in, which is number of goals. Here, the data is discrete, so there's only one real option in terms of how to set up the horizontal axis, and that is we're going to go 0 to 9 by ones. The vertical scale now is going to be relative frequency, or how I prefer to call that is probability. The most common thing that happens is this hockey team scores 3 goals with a probability of about 23%. So I'm going to label the vertical axis here based on probabilities. I'm going to go in 10% increments. So now when we draw the histogram, remember one of the characteristics of histograms is that the bars touch. So the likelihood of 0 goals is 6%, a little bit above my 5% there. 15% of the time they score 1 goal. 22.8 or about 23% of the time they score 2 goals. Also about 23% of the time they score 3 goals. They score 4 goals about 17% of the time. Then 5 goals about 10% of the time. 6 goals about 4% of the time. 7 goals about 1.5% of the time. And then the probabilities of 8 goals and 9 goals get pretty small. Okay. Now, in determining the mean and the standard deviation, we can do these things by hand. For the mean or the expected value, it's the sum of each outcome weighted by its probability. So that'd be like 0 will show up 6.1% of the time in the long run, and 1 will show up 15.4% of the time in the long run, etc. And because there's so many computations here, I'm going to go ahead and recommend that on this problem, we go ahead and use the TI-84. So the way we do that is we're going to set up the probability table in L1 and L2 of our calculator. So L1 will be the numbers 0 through 9. And then in L2, it's going to be the probabilities that go along with it, all the way down to that last probability of 0.001. Now, in order to get the mean and the standard deviation, it's going to be a 1var stats command. And when you do the 1var stats, there's going to be an XList option, and that's going to be L1. And now this will be the first time we'll actually use the frequency list option in L2. That's where the probabilities go, and then we'll hit calculate. So I'm going to just plug these in real quick to verify we get the same answers. All right, so I'm just grabbing my calculator here real quick. L1, I'm putting in the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Has to be really exciting to listen to me pound numbers into a calculator while watching this. So now the probabilities I'm putting into L2. Hopefully I don't mess any of this up. Okay, so I got all this stuff in. Now I'm hitting my one var stats button, list L1, frequency list L2, hit calculate. The calculator is going to give you the symbol X bar, but that top statistic is really, should have the symbol mu. 2.851 is the average number of goals scored per game by that NHL hockey team. And then the symbol for the standard deviation, lowercase sigma, that's 1.632, etc. You can round it off as you see appropriate. But now that means that standard deviation is the average difference between the actual number of goals scored in individual games from the mean amount of goals scored. So it kind of shows you a measurement of variability in their performance. Anyway, we should be able to take that information and apply it to the book problems I want you to do in class. Thank you.